Hello everyone! Today we're diving into software reliability, why it matters, and what it really means. Think of it like a toy robot. You expect it to work every time you turn it on. Software reliability is about software doing its job correctly, every time, without crashing or giving wrong results. For example, a calculator app should always give you the right answer. If it sometimes says 2 plus 2 equals 5, it's not reliable. Reliability means the software works as expected over and over for as long as you need it. It's not just about working once, but being dependable every time you use it. Consistency is key. You want your favorite game or app to work smoothly, not just for a few minutes, but every time you use it. Software also needs to work well in the environment it was designed for, on the right devices, with the right operating systems, and under expected conditions. On the right devices, with the right operating systems, and under expected conditions. If an app works on one phone but crashes on another, that's a reliability problem. Engineers aim to make software robust enough to handle these variations. In short, software reliability is about trust. You can count on it to do what it's supposed to, whenever you need it. That's why it's a fundamental quality for any software you use. Let's see why this matters so much. Why is software reliability such a big deal? Unreliable software wastes time, causes frustration, and can make us lose important work, like when a document editor crashes before you save. If a banking app shows errors, you might worry about your money's safety. For businesses, unreliable software means lost customers and revenue. Nobody wants to shop on a website that keeps crashing. Fixing unreliable software is expensive and damages a company's reputation. In critical areas like healthcare or transportation, unreliable software can be dangerous or even life-threatening. Medical devices, air traffic control, and modern cars all depend on reliable software to keep people safe. Reliable software is also easier to maintain and more secure since fewer bugs mean fewer vulnerabilities. Ultimately, reliability is the foundation for trust, safety, and quality in all the software we use. That's why it's a top priority for engineers and users alike. Let's make software reliability clearer with some real-life examples. Imagine a calculator app. If it always gives the right answer, it's reliable. If it crashes or gives wrong results, it's not. Or think about streaming video. If your show buffers constantly or the app crashes, that's unreliable software ruining your experience. Users expect things to just work every time. Engineers use concepts like the bathtub curve to track reliability. Early failures are common, but after fixes, software should run smoothly for a long time. Over time, new problems might appear as technology changes. Reliability also depends on every part of a system working together, like an online shop where search, database, and display all need to function. If any link in the chain fails, the whole experience suffers. That's why engineers focus on making every component dependable. Reliable software means smooth, predictable experiences for users. It's about making sure things work not just once, but every time. Now, how do we actually measure this reliability? So, how do engineers measure software reliability? One key metric is mean time between failures, MTBF. The average time software runs before something goes wrong. The higher, the better. Another is failure rate, how often failures happen. Lower is better. For example, if a system runs 1,000 hours and fails twice, the MTBF is 500 hours. Engineers track these numbers to see if their fixes are working and to set goals like 99.9% uptime. Availability is another important measure. It's the percentage of time software is up and running for users. High availability, like 3 nines, 99.9%, means very little downtime. These metrics help teams spot problems, improve reliability, and ensure users can depend on their software. Measuring reliability isn't just technical. It's about making sure people can trust the tools they use. Let's look at why this matters in the real world. Software reliability impacts our lives every day. In banking, unreliable apps can cause missed payments or incorrect balances. Trust is everything. In healthcare, software runs devices like pacemakers and infusion pumps. A failure could be life-threatening. Hospitals rely on reliable systems for patient records and prescriptions. Mistakes aren't an option. Transportation depends on software for cars, planes, and trains. A glitch could cause accidents. As technology advances, reliability becomes even more critical. Think self-driving cars or automated trains. For future engineers, mastering reliability is a core responsibility. It's about building products people can trust for safety, business, and daily life. Reliable software shapes a safer, more efficient world. Make reliability your priority, and you'll help create technology everyone can depend on.